how are we doing? Okay, so problem 14 in problem set 6 gives us this Wheel of Fortune, and it's not Pat Sajak's. It has the numbers 1 through 100 on it. Now if one player wins with multiples of 3 and 7, and another player wins with multiples of 4 and 6, we want to know that if we give this a spin, what is the probability that the dealer will win? So I have that scenario written up here. The dealer will win with anything other than multiples of 3, 4, 6, and 7. So because we want just the dealer's chance of winning, we can consider players 1 and 2, their chances of winning, together. So we'll find their chances of winning, and we'll add them up. We'll subtract them from 100 to get the dealer's chances. So we want the multiples of 3, 7, 4, and 6 in 100. And to do that, we'll just divide 100 by each of these numbers. Simple as that. Well, not really, but we'll see when we get there. So 100 divided by 3 is 33 and a third, right? But because we're dealing with multiples, multiples are only integers, they're not fractions or decimals, so we truncate that decimal there, and we just have 33 multiples for 3. 7 in 100 would be 1 minus 7 is 3, carry down the 0, 30, 28's the closest there, so 14. And we add those together, and we get a 47. On to player 2. This gives us a nice round number with 25. Now because we're considering both the player's chances together, both player 1 and player 2, we already covered the multiples of 6 and the multiples of 3, right? Because every second multiple of 3 is a multiple of 6. So I'm not even going to include multiples of 6 right now. And then you might think to yourself, well, hang on, that's not the only redundancy, is it? No. We also have redundancies in every third multiple of 4, or, fourth multiple of 3, every third multiple of 7, or seventh multiple of 3, and every fourth multiple of 7, or seventh multiple of 4. So we'll get there. But we missed one. We missed a multiple of 3, 4, and 7, and there's only one multiple from 1 to 100 for 3, 4, and 7, and that's 84. So 3, 4, and 7, multiple 84, and that'll be one more that we're going to add to our grand total of multiples. So that would be 13 there, and 73. Now that's without those redundancies. So now we have to find those redundancies, and we can either do, say if we're taking those of both 3 and 4, we could either do 33 are multiples of 3 divided by 4, or multiples of 4 divided by 3, and I'll just do multiples of 4 divided by 3. So 25 divided by 3 would be 8, because that would be 24, that's our closest. 8. And multiples of 3 and 7. Let's do multiples of 7, 14 divided by 3. And that will be 12, which is 4. And then multiples of 7 and 4, so 14 divided by 4. Again, that's 12, so that's 3 if we're dividing by 4. And then 8 plus 4 plus 3 is 15. So those are essentially the numbers that we counted twice when we found these multiples. So we have to subtract them from our total number here. 8 and 58. But that's not our answer. See, that's the chances out of 100 that either player will win. So as I said, we subtract 100 and 58. And we get 42 out of 100, or a 42% chance that the dealer wins. So there it is. Ooh. Take a good look at that there, yep. And yeah, pretty good, I think. See you around.